Hello student, today we are learning about uniform circular motion of class 9. Listen carefully. Firstly, uniform circular motion is just a part of rotational motion, or we can say circular motion. Actually, motion is that a thing which just depends upon observer. It is just specified by the observer whether it is linear, whether it is random, whether it is circular. Every type of motion is just depends upon the viewer. Now let's see on the board. If we have a circular path, and observer is at the center of that path, and a body moves from A to B, then observer just without any change its position, he observed the motion of the body from A to B. In that case, we can say observer makes an angle, let that angle is theta, on his eye to observe the motion of a body from A to B. This condition is known as circular motion. Even the body from A to B moves in a straight line path, because for him that motion is a linear motion. But if the observer is at O, at origin, then for that observer, the motion of the body from A to B, when it makes an angle theta on its eye, then it is called circular motion. Now, if in the same diagram, if the body in time t go from A to B, and next equal time t, if it moves from B to C and makes the same angle theta on the eye of the observer, that means at every instant if a body makes equal angle, subtended equal angle on the viewer's eye, on the observer's eye, then that motion is called uniform circular motion. So uniform circular motion is simply defined as the motion at that type of circular motion in which a body makes equal angle in every equal interval of time along a circular path on the eye of the observer or on the origin of the circular path, then that motion is called center of the circular, then that motion is called uniform circular motion. For one complete rotation, now if we say to complete one rotation, in one complete rotation, the total linear distance covered by the body along a circular path is equal to 2 pi r, where here r is the radius of the circular path. That means if along a circular path, when the viewer is at center of the circular path, body moves A to complete one of its rotation, then the total linear distance is given by 2 pi r, that is the circumference of the body. Obviously, we can say now, if we take the total linear distance, that means theta total, it is the, for one complete rotation, the total angular distance, that is theta total, is equal to 360. But theta total is actually written as 2 pi. 2 pi is a radian value of 360 degree. So we can say, because pi is equal to 180 degree, hence we can say that 2 pi is equal to 360 degree. So we can say that S is equal to theta total into r. S is equal to theta total into r. Now dividing time on both sides, S by T is equal to theta total into r by T. T is the time. And we have S by T is equal to V. That is the linear velocity. Linear velocity and theta total by T is equal to omega. That is angular velocity. We know that we know about the omega. That is omega is the angular velocity. A-N-G-L-A-R, angular velocity of the body. So we can say that, so from the above formula we can say that V is equal to omega r. That is the relation between linear velocity and angular velocity in the case of uniform circular motion. So in uniform circular motion we can say that the linear velocity is equal to the product of radius of the circular path and the angular velocity of the body. So this is the part here about the uniform circular motion.